Okay, today we're going to take a look at the sum and difference formulas, so let's go ahead and start. Learning goal. Students will be able to use the sum and difference formulas. Very useful tool in pre-calc and in calc. So here they are. It's the sum and difference formulas for sine and cosine. The first one is for sum, and it says sine A plus B is equal to sine A times cosine B plus cosine A times sine B. The nice thing about sine is it keeps the same sign. Alright, the difference. Same idea, but in this case it's going to be a minus. So sine A minus B is equal to sine A times cosine B, keeps the same sign, minus cosine A times sine B. Alright, you're doing great. Sum for cosine. Cosine A plus B is equal to cosine A times cosine B, opposite sign. So minus sine A times sine B. And last but not least, difference is basically cosine A minus B is equal to cosine A times cosine B plus sine A times sine B. Once again, notice that both of these have opposite signs to what is given to you. Now, if you're like, why do I even need this? Well, basically, we've only dealt with stuff like this, sine of 45 degrees. So we've basically dealt with reference angles. And if it wasn't a reference angle, we were able to make it a reference angle. But what if I did this? Sine of 75 degrees. That's not on the unit circle. So to be able to do this, we need to break 75 degrees into two different reference angles. So that would be definitely 30 degrees plus 45 degrees. And so then we would go back to our properties of sine and cosine for the sum and difference. So that's basically why we need it. And I said earlier that not least, what I meant by that is this. Cosine was last but not least because we still have tangent. So sum for tangent, tangent A plus B is equal to tangent A plus B over 1 minus tangent A times tangent B. The difference is tangent A minus B is equal to tangent A minus B over 1 plus tangent A times tangent B. Okay, so let's go ahead and let's put all of those into perspective. So let's go ahead and start. Cosine of 75 degrees. Now, like I said, 75 degrees is not a reference angle, nor will it ever be a reference angle. But I can split it up into two pieces. So I can say that cosine of 75 degrees is the same thing as cosine of 30 degrees plus 45 degrees. And so here I would need the actual formula for cosine and a plus. So if you don't remember, let me refresh your memory. Cosine of A plus B is equal to cosine A times cosine B, opposite sign, minus sine A times sine B. So that's what I'm going to plug in. Okay, so let's give it a go. This makes basically cosine of 30 degrees times cosine of 45 degrees minus sine of 30 degrees times sine of 45 degrees. Now, if you don't recall what sine and cosine is in terms of 35 and 45 degrees, we can construct just a little mini part of the unit circle. Not a problem. At this point in time, you should hopefully have them in your long-term memory, but it's okay if you don't. So basically, I'm just going to do my little trick. 1, 2, 3 down, 1, 2, 3 up. Stick them all over 2. And then basically, just take the square roots of the top. Okie dokie. So cosine of 30 degrees is just going to be radical 3 over 2 times 45 degrees is radical 2 over 2 minus sine of 30 is 1/2 times sine of 45 is rad 2 over 2. Okay, so this makes radical 6 over 4 minus radical 2 over 4. If I simplify that a little bit further, radical 6 minus radical 2 all over 4. Not too bad. So that's what it's equal to. That's the exact value. We didn't even use a calculator. Alright, so the next one. Now, if you're not comfortable with radians, you can definitely get it into degrees and then handle your business that way. So let's do that. Pi over 12, to make it into degrees, I'm going to multiply by 180 over pi. Those will cancel, and when I simplify, I get 15 degrees. Now, 15 degrees is most definitely not a reference angle. But what we can do is this. We can try to figure out what makes 15 degrees. I would say 45 degrees minus 30 degrees. That would generate 15 degrees. So let's go ahead and do it then. Let me grab Mr. Green and write out the formula. So the formula for sine A minus B is equal to, okay, the sine stays the same. It's going to be sine A times cosine B minus cosine A times sine B. Just something you have to memorize. Alright, if I rewrite this, I get sine 45 degrees times cosine of 30 degrees minus cosine of 45 degrees times sine of 30 degrees. Okay, sine of 45 degrees is radical 2 over 2. Cosine of 30 degrees is radical 3 over 2 minus rad 2 over 2 times 1/2. And here you get radical 6 over 2 minus radical, oh, almost made a mistake. 2 times 2 makes 4. Radical 2 over 4, which makes radical 6 minus radical 2 all over 4. Now, if you're wondering why the heck we got the same answer twice, I have a little inkling that these are cofunctions. So in an earlier video we talked about sine and cosine and all the rest of the trig functions having cofunctions. Basically we have 180 minus theta. Well, that's what's happening here, and that's why they're the same. Alright, so I hope you're getting a good feeling for this. Oh my gosh, look at this. We're doing a sum and a difference. So let me go ahead and let me write down the formulas for you real quick. Sine of A plus B is equal to sine A times cosine B plus, keeps the same sign, cosine A times sine B. And for the second one, it's the same thing, just opposite sign. So let me go ahead and use my eraser, and let me draw a negative there. Okay, so it's going to be sine A cosine B minus cosine A sine B. Okay, let's give it a go. Take a deep breath. Alright, let's do it. Sine of 45 degrees times cosine x minus, or actually plus, keeps the same sign, cosine of 45 degrees sine x plus sine of 45 degrees cosine of x minus cosine of 45 degrees sine of x. So I just use these two. And now let's see if anything will cancel out. Let me grab Mr. Red. This and it looks like this will cancel each other out. The other two you can actually combine. So you get 2 sine 45 degrees of cosine x, and then sine of 45 degrees is radical 2 over 2, so you get 2 times radical 2 over 2 times cosine x, and that just makes, in this case, radical 2 cosine x. Hopefully it's not too bad. Okay, example 4. Now, 42 degrees and 12 degrees. No matter how hard you try, there's not two things in terms of reference angles that will add or subtract to 42, nor are there anything that I can add or subtract to equal 12 degrees. So what I would recommend on some of these is really take a look at this. Does this look familiar to anything that we've seen earlier today? It's not a trick question. Basically, if I recall sine of A minus B, I got sine A times cosine B minus cosine A times sine B. So basically, if I replace the A's and B's with 42 degrees and 12 degrees, which I'll do right now, you get sine of 42 degrees minus 12 degrees, which is equal to sine of 42 degrees times cosine of 12 degrees minus cosine of 42 degrees, I'm running out of room here, times sine of, in this case, 12 degrees. So you can see that this is the same thing as this. So we're going backwards. We're going to go to sine 42 degrees minus 12 degrees. And if we do that, we can see if we subtract these, you just get sine of 30 degrees. And so that's just equal to 1/2. So really take a look at the actual trig functions that are given to you guys, because it might be something where they actually plugged in for you and they want you to go backwards like we just did. So the answer is going to be 1/2. Okay, so let's scroll up and let's see if we hit our learning goal. Students will be able to know and use the sum and difference formulas. I truly believe you're going to be able to do it. You just need to just basically memorize them. So I know that's a bad word for a lot of you guys, but the more you know in terms of just being able to create them really quickly, the easier it's going to be to do the problems. Okay, I'll see you on the next video.